Okay, today we're going to have a look at odd and even symmetry in functions, and this will relate to exercise 3.03 in the Maths and Focus textbook. Okay, let's start here at functions are even. Functions are even if they are symmetrical or reflective about the y-axis. And a parabola is an excellent example of an even function. We have a look at the parabola here, y equals x squared. We would say that it is symmetrical about the y-axis. If I folded that, if it was on paper and folded along that y-axis, this side would match on top of this side exactly. So we call that symmetrical, and that's an example of an even function. Pretty much any parabola that has a power that is an even number will be an even graph. So y equals x to the 4, y equals x to the 6, etc. would be even. So we can either look at them graphically, but there's another way we can work them out, and that's the rule here. And we have a rule that says for even functions, the function itself, or f of x, is equal to the function of minus x. So if we can get that to work for a function, then that is an even function, if that is for all values of x. And there's a little note here to the side. Even powers turn positive. So if I'm squaring minus x, I end up with x squared, because I'm squaring that minus there, that becomes a positive, and I'm squaring the x, which becomes x squared. And that would be the same for any even power, and we'll use that in our rule in a moment. Now, they were even functions. Now, a function could be odd. Now, a function is odd if they have what we call point symmetry about the origin, i.e. it's rotated 180 degrees about the origin and gives the original graph. So let's have a look. Example of this one, a good one, is the cubic. So here's the graph of y equals x cubed. If I have a look at this right-hand side of my cubic, so where x and y are greater than 0, if I rotate that through 180 degrees, so I bring that around here and down to here, I get that same part of that graph again. So that's an example of an odd function. It's rotated through 180 degrees, or it's basically reflected through the y and then reflected through the x again. And that gives us two lots of 90 reflections, and that's an odd function. Now, that's graphically what one would look like, but we can test that using our algebra as well. So to decide if a function is odd, if we work out what the function of minus x is, and then we work out what minus of that function is, and if those two are equal, then that is a test that tells us that a function is odd. Just a little note about odd powers. Minus x all cubed would become minus x cubed, because minus 1 cubed is still minus 1, and x cubed becomes x cubed. And that same thing would happen for any odd power. So that's a good little tip to note when we're working these out. Okay, well, let's have a look at the ones I've got down here. This is a little bit tricky, these three here, but we are going to be learning in the next few weeks how to plot them, how to sketch them, but we're going to have a go at it today. But the main thing here is deciding whether each of these 1, 2, or 3 are odd or even, but you can actually have graphs that are neither odd nor even as well. So if they're not symmetrical around the y-axis, or they don't reflect through 180 degrees, they don't actually have to be odd or even, they can be neither. So let's have a look at this first one. F of x equals x squared minus 2. Now what I've done is I've circled that 2 and put a little arrow there to say even, and I've got a question mark. I'm guessing because it's a power of 2, it's probably going to be even. You will get really good at being able to draw this graph, and you will find that in a few weeks' time you will look at that and you'll know straight off that it's even. But let's test it. So I'm going to test for even, and the even test was that f of x is equal to f of minus x. And if that's true, then it's going to be even. We've got f of x, that was the question, that is x squared minus 2. Let's check f of minus x. So we're just going to place minus x wherever we had an x in our function. So f of minus x is minus x squared minus 2. And we know that minus x all squared is x squared, and we still have a minus 2. So f of minus x is x squared minus 2. So if you need to pause the video and work that out for yourself, go and do that. But that's the same as our function. So the even test works. F of x is equal to f of minus x. So this is an even function. But what it actually asks us to do in the question is not just to classify them, it's just to sketch it. So let's have a little go at sketching. Now remember, what I've been telling you in class is a sketch is not a plot. We're not putting values in for every single value. We're just getting a rough idea of what it looks like, and that is a sketch. Sketches are fine, and it makes time Gives us a little bit more time to work on the question so we're not wasting time plotting that question. Generally, when we're sketching, I'm looking for two things, where it cuts the x-axis and where it cuts the y-axis. However, when we get really good at this graph, in terms of graphing x squareds, we'll see we know what y equals x squared is equal to. We had a look at that over to the right here. Where are we? Up here. That's y of x squared, and we've got y of x squared either moving up or down. So let's look what our one tells us. It tells us it's going down by 2. So we're basically having y of x squared here moving down to minus 2. And our graph will come down here and up here again. And that's x squared minus 2. But if you didn't know that, and you know, you may not, we need to work it out. So let's look where it cuts the x-axis. It cuts the x-axis at y equals 0, or f of x equals 0. So all I've done is place f of x equal to 0, and we've got x squared minus 2 equals 0. That's a difference of 2 squares, if you can see it like that. If not, I'm going to move the minus 2 to the other side by adding 2 to both sides. So I get x squared equals 2. Take the square root, and I get plus or minus root 2. That's when my parabola cuts at those 2 points. Now we can have a look at where it cuts the y-axis. It cuts the y-axis at x equals 0. So we're just going to go back to our little function. We're going to pop a 0 where x equals 0, and we're going to see that the function is equal to minus 2. And so it cuts the y-axis down at minus 2, and I can quickly graph that. And that's what the sketch looks like. Let's go to the next one. Okay, let's have a look at f of x is equal to x cubed minus 4x. Okay. Now, I've circled the 3 and put an arrow up there and got odd and a question mark. I'm assuming or guessing that this is a cubic, and it's probably going to be odd because most cubics are odd, but not always. So instead of doing the even test and the odd test, let's just start with the odd test. And if that doesn't work, then we might go back to even. So here's our odd test. A function is odd if f of minus x is equal to minus f of x. So f of minus x, wherever we see an x up here, we're going to place a minus x into that instead. So f of minus x is equal to minus x all cubed minus 4 times minus x. Minus x all cubed is minus, because when we cube a minus, we still get a minus, x cubed. So we get minus x cubed. We've got a minus here in front of our 4 and a minus in front of the x. Multiplying those guys together, and we get a plus. So we get minus x cubed plus 4x for a function of minus x. Now let's see what minus our function of x is. So that's minus that whole function, okay? And then we have to multiply that minus through each term. So we end up with minus x cubed plus 4x. And what you can see is those guys are the same. F of minus x is equal to minus f of x. So tick, it is an odd function, which is what we thought it would be. Now, we know the generic form of function x, or y equals x cubed. We did that up here, and we had a look at that to the right. I quickly sketched that. That's y equals x cubed, and it cuts through at 0, 0. However, we can't guess this one as easy as the other one, because it's moving down by 4 lots of x. So we're not really sure where it's going to cut our axes. So we need to look at that a little bit further. So remember, to sketch this, we need 2 things. We need to figure out where it cuts the x-axis and where it cuts the y-axis. We're not plotting all the points. We're just getting a general gist of what the graph looks like. Now, we've learned that a graph cuts the x-axis at y equals 0 or function x equals 0 because they're the same. Okay, so all I'm doing is placing my function equal to 0. Okay. Now, we don't have a rule to factorize a power of 3, but what you'll notice is I can factorize by pulling out an x out of each of those terms, and what I'm left with then inside my brackets is x squared minus 4, and I've still got it equal to 0. This part inside here is a difference of 2 squares. So I've got x minus 2x plus 2 equals 0. What I need to do to find my x values is I need to set each of those parts with an x in it to 0. X equals 0 is my first one, so that's good. We've got one already. X minus 2 equals 0, and x plus 2 equals 0. We've got our x equals 0. We need to solve these two, and I'll end up with x is positive 2 and x is negative 2. So my cubic is going to cut the x-axis at 3 different points. 0, 2, and minus 2. There's a little minus in there. They're my 3 points. And it cuts the y-axis, and we've already got one of those, at x equals 0. So if we just quickly pop that in there, it's going to be 0 minus 0. So it cuts the y-axis at 0. like that. Okay, now, something we need to know when we're graphing, okay, is yes, we have 3 points, but which way does our graph go? Now, we need to have a look at whether it's a positive cubic or a negative. And we're going to do more of these in the next few weeks. So don't panic if you're finding this a little bit difficult, because it is different and it is new. So we don't have a negative out the front of that cubic, so it's a positive cubic. So my cubic is going to start up in this quadrant. Okay, it could have gone this way if it was a negative, but it's not. It's starting in that positive quadrant where y is positive and x is positive. And then I just follow through and around. I don't yet know what these values are, where it turns, sorry. That's coming up in the next few weeks. We'll have a look at those. Okay, lucky last. And we didn't get this one done in class the other day. F of x is equal to x squared plus 3x. Now, I've circled it and I've put an arrow across the 2 and said, oh, I think it's even. It's actually not going to, but we don't know that yet. So let's check for even. A function is even if f of x is equal to f of minus x. Now, don't forget we're checking for even or odd because we've been asked to check for even or odd. Okay, you could not normally do this in sketching a graph, but the question has asked us to do this. Just reminding you that that's why we're doing it. So here's our test for even. Okay, we're checking that f of x is equal to f of minus x. Well, here's our f of x. That's the question. F of minus x. We'll pop a minus x in where x is. So minus x squared plus 3 times minus x. That gives us x squared minus 3x. Does f of x equal f of minus x? No. So it's not even. Okay. Let's have a look at the next one. Let's check for odd. The odd test is, let's pop that there, that f of minus x is equal to minus f of x. Okay, we've got minus f of x because we just worked that out above for the even function. Let's find minus f of whole x there. So I'm going to pop a minus in front of each of these terms, or out the front and pull it through. I'll get minus x squared minus 3x. So there's this one here. Does it equal? No. So it's not even and it's not odd, and that is okay. You can have graphs that are not even and not odd. That would just mean they're not symmetrical about the y-axis, or they don't rotate through 180 degrees or flip through the y and then the x. So if you have a look at the graph below, you'll see why that's the case. So what we need to do to sketch it, we need to know 2 things. We need to know where it cuts the x-axis and where it cuts the y-axis to sketch our graph. It cuts the x-axis at y equals 0, or f of x equals 0. So this goes to 0, and we've got this term left here. Let's pop it in here. So 0 equals x squared plus 3x. Let's factorize it. Pull out an x. I get x brackets x plus 3. To solve, I set each of those to 0. I get x equals 0, and x is equal to minus 3. They're my 2 points where it actually cuts the x-axis. So just here and just here. Where does it cut the y-axis? It cuts the y-axis, x equals 0. So if I pop 0 into each of those, I get 0 plus 0, so it cuts at 0. And that's our point there. So here's what our graph looks like. And we're not worrying yet about this point down here. We'll get to that soon. Okay, so what you can see if you're looking at that graph, it is not symmetrical about the y-axis, is it? Okay, because that would be the point where it's symmetrical around is here. It's not rotated through here, so it's flipped down here. Through the 180, it's not at all looking like that. So it's not even and it's not odd. So we can see graphically that it's not even and not odd, and we worked out algebraically that it's not even and not odd as well.